All right, everyone. Thank you for joining us again for the data engineering meetup. We're very happy to have you here. So this is your host Noel Hansons for this evening from the Melbourne Data Engineering Meetup. With me here as hosts we have Peter Hansons and Simon Aubrey from the Sydney Data Engineering Meetup, and Francisco Liwa from the Brisbane Data Engineering Meetup. I like to start off these meetups with a very short joke just to get everyone eased in and in the mood. And I've got a particularly special one this evening, and that is how do trees join online conference calls? They log in. Right. So with that in mind, we'll keep going. I want to quickly hand over to a wonderful supporter of ours, Michelle Playfair from Yao Conferences, who will just say a few words on our behalf. So let me hand over to her. Michelle, do you want to say a few words?
A very few words. Okay, yep. So we have a little poll. If you haven't seen the poll and you are with us here in, oh dear, I just saw another bad joke. Someone says they think they might leaf. What have you done to us, Noel? Yeah, cheers. Thanks, Luke. So there's a poll. If you are in Zoom and you kind of scroll down a little bit to where the menus are, just curious to see who has heard of Yao Conferences before. If you have not, we are a company that does conferences based in Australia. We've also been in Singapore and Hong Kong. We were going to be in New Zealand this year, but yeah, something pandemic, something. And because of said pandemic, our regular Yao Data conference was unfortunately cancelled. But like the phoenix rising from the ashes, we are now going to be online. So if you go to yaoconference.com/data or data, you choose, you can see we've got a pretty good lineup. For those of you who are into data engineering and who isn't in this group, we have Claire Carroll speaking, and also Fabian, whose last name we probably will stop butchering until we figure out how it's pronounced correctly. And I see there's a few people from Splunk here, so you probably know Karthik. And he's going to be speaking as well on the data engineering track. So we're splitting it out over 3 days to try and avoid screen fatigue. So we're not doing a full day in front of the screen. We're going to do some talks in part of the day for data science, and then data engineering, and then machine learning on 3 days. So if you go to our website, yaoconference.com/data, you'll be able to find out more information. The ticketing is going to be done through a membership basis. So it's a bit of a save the date at the moment because we haven't hooked up the ticketing yet. So you cannot actually yet purchase tickets. Hopefully you'll be able to get your companies to buy them for you. But yeah, it's pretty affordable given that it's online and we don't have travel expenses and such. So hopefully we will virtually see you all there. It's kind of set so people should be able to join from various time zones. So the talks are arranged for speaker and attendee convenience, and hopefully we'll be able to cover most of the time zones around APAC as well as some US convenience and European convenience. So hopefully we'll see you all there. And yeah, cheers. Thanks very much, Noel.
Thanks, Michelle. So I wanted to let everyone know that so we're on Zoom tonight. Our data engineers meetup Slack is there, of course, and we also have we're live on Twitch this evening. So please join us on all three if you can. Why not? Get in. So this evening we're very fortunate to have Tim Gerber from AGL speaking about establishing a value-driven cloud analytics asset. And then following on from that, we'll have Jeff and Eric from Splunk talking about playing with data pipelines on Kafka, Pulsar, and Flink. So without further ado, I'll hand over to Tim. Thank you, Tim.
Thank you, Noel. Let me just bring up my screen. Great. Now, the last engineering meeting I went to, I actually provided the pizzas and the drinks, but unfortunately, all we got is a couple of biscuits this time. So I'll share them out later. I hope you don't mind. So I'll enjoy them later in the meeting. But I'm keen to have a chat to you guys what we actually did over the last couple of years that I've been at AGL. And I'm actually not a very technical person. I'm more of a people leader. So, but feel free to ask me some technical questions and I'll see if I can answer them. But a quick introduction to myself, and I think we need to always start off with a bit of an action shot. So that's me hiking the Razorback Trail in Mount Hotham last year with my lovely wife. Look me up on LinkedIn. I'm Melbourne-based. I actually live outside of Melbourne, but I'm Melbourne-based when we're allowed to be in the office. So look me up on LinkedIn. I'm quite keen to have coffees with people and have a chat. But I've been in data now for about 15, 18 years. Been in banking all my life, and I've just moved into the energy sector in the last couple of years, which has been a great journey to be in. But I've done the NAB thing, I've done the overseas thing, and I've done the local bank thing. So I'm pretty banked out. So happy to move into energy. So who is AGL? And some of you, I'm sure most of you have heard of AGL, but we are one of the leading energy providers in Australia. We actually generate about 20% of Australia's energy, which is pretty amazing. So if you look up in the roof, 20% of all those lights are generated by us. And we're also one of Australia's oldest companies, obviously starting in Sydney back in about 180 years ago. So it's a long and well-established Australian business. So that's also one of the reasons why I was keen to work for AGL. So we are mainly leaders in gas and electricity, are our main players, and we're moving towards renewables sort of by 2050 is the plan at the moment, with 3.7 million customers. So we're quite large, and we are one of the two big ones, obviously. We've got three simple strategies, which is around optimizing our existing portfolio around value. And the reason why I call these out is because these are the key things that I called on as we started building the data platform and data strategy, as we started building that. AGL is very, very proactive and open and involved in the community around creating new opportunities and connecting with customers. We are very keen for that, and we have recently entered into the data space by purchasing Southern Phone Company, and we'll probably do more of them in the future. But when I joined AGL nearly 2 years ago to the day, actually, I think it is actually my 2-year anniversary. This is pretty much what the data landscape looked like. Now, when I was making this presentation, I just Googled complex data. This is the first thing that popped up, so I grabbed it off the internet. But this is pretty much what our data was like. I remember coming into AGL and asking a few simple questions like, where's our data warehouse? The answer was we haven't got one. And the next question is, where are our data sources? And it was the same sort of conversation that I've heard, and you guys probably heard in other organizations, is we have multiple warehouses, and we don't really know which one is the right one to look at. So that was, to me, honestly, was mind-boggling to walk into a large organization as we were 2 years ago and to really have those challenges. I was expecting something different. But that was good opportunity. I think it's often easier to walk into an organization that is lacking some maturity. So what we did is we were fortunate enough that it was actually the same time that a number of other key influencers were coming into AGL. So it was a real groundswell to actually do something different than what we've done in the past. And some of these resources were key influencers inside mainly customer market space, and they were very mature and passionate about driving data for their business. So we engaged a few external partners to help us with this, and as I think you often need to do during these times. And we started looking at what are the key issues that we've got or challenges that we're actually looking at. And this was through a number of interviews with influencers across AGL. And some of these will be quite familiar to what you've experienced in your career, or even maybe familiar to what your current experience is. But there was a couple of real call outs here, and this really reflected strongly to my observation of the organization. There was a lack of direction, and we just didn't really know where we were going. And I've used the word in other presentations I've done, but we were suffering from technology tourism in the data space. We weren't really sure. We're flicking between one new idea and one, another idea, and we'd followed the Hadoop train. We'd done everything. But but we didn't really know which, like the architects were struggling. They weren't aware of how to define a solution because there's no architecture blueprint or any clear direction on which way they should be designing a solution. So that was concerning. The fundamentals are missing. So I think it was, what I meant by that was we just, we didn't even have the basic stuff. Like we didn't even have, some kind of warehouse that would really be called a data warehouse. We had databases all over the places, but no real data warehouse. And we have been doing a lot of stuff just tactically. Like we were innovating left, right, and center with no productionization of any other innovations. So we're always just trying something new, which is great place to work, but you can't do that forever. Like every organization, there was a lot of data that was underutilized.
Hi all. I might just jump in here because it appears as though Tim has stopped. I'm just checking to see if everyone can hear me now. So if you can, please just message on Zoom to let me know. I'm turning on my video as well. So can you hear me there, Peter?
Yeah, gotcha.
Yep.
Yeah, it does look like Tim might have dropped off.
Yep.
Yeah, good old NBN.
This is called regional NBN.
Which is okay. This is actually, while we're trying to get Tim back on the line, we'll quickly switch to Simon. Simon's got some fantastic words to say about a new conference called Data Eng Bytes. So Simon, if you're free, mate, I'll just switch to.
Oh, absolutely. Could you just switch on my video?
Yep. Just give me a moment. Sorry, that's Peter for you to chuck on, and that should. Yep.
Do you want to share your slides as well, Noel?
I just have, mate. Yep.
Fantastic. Well, this is very exciting. Hopefully you can see a splash banner introducing data engineering bytes. So hopefully you can all see that. Very, very quickly, this is a data engineering conference produced by data engineers, delivered by data engineers, and oddly enough, organized by data engineers. And I think that this will be relevant and of interest to everyone joining us tonight. So Data Engineering Bytes, it's a 2-day conference on Thursday the 20th and Friday the 21st of August. And we're hoping that we can have everyone join in and participate. This is going to be a virtual Australian conference focusing on real-world data engineering problems. It's a not-for-profit event, and we're going to have 2 half-day sessions jam-packed with amazing presentations, sharing, learning, all centered around really, really cool data engineering challenges, both problems and solutions. So our ask of everyone today is have a level of awareness, but also really be interested to get you all involved. If you want to speak, submit a talk. Even if you only have an idea, I'd really encourage everyone to consider sharing their stories around data engineering. Even if you have an idea, would love to have you consider yourself as a potential speaker. And we've got a way of supporting first-time speakers. If you feel that you've got a good engineering problem to share, but you just need a bit of support getting that out there. We'd love to support first-time speakers. If you want to attend, I'd love you to get involved and register. The tickets will be of that magic price tag free. And if you want to get updates, join our newsletter. We'll flick out the link in a moment, but put your email address down and then you'll get updates for all of the excitement building for Data Engineering Bites. So remember those calendar events, Thursday the 20th and Friday 21st of August. Really looking forward to having everyone involved and coming along for Data Engineering Bites. And if you enjoy this meetup tonight, you're going to love Data Engineering Bites coming forwards. Thanks.
Thank you, Simon. Really appreciate that. Now, usually I would switch to my emergency list of jokes in situations like this, but fortunately for all of us, I think both Jeff and Eric from Splunk are ready to go with their talk, so you won't have to be subjected to that. So, so Jeff and Eric, if you're ready to go, I might hand over to you and get you to talk to do your presentation on playing with data pipelines in Kafka, Pulsar, and Flink.
Sweet. Are you seeing my slides?
We are, mate.
Cool. Tim's just back. If he's good to go, I'll let him complete his presentation.
He's literally come back on just as you're about to start, Jeff. So thanks for that. Tim, are you on as a panelist, mate, or just as an attendee? Because I'm not seeing you in the panelist list.
I'll fix that up. 1 second.
Yeah.
Tim, you should be a panelist now.
And if you're ready to go, Tim, you can reshare your slides and kick off.
So I really apologise for that, but it was a total blue screen of death. That one.
No problem, mate.
The choice of it.
Yep.
Sorry, I'll just need to back to it. Okay. Sorry. So back to it. Sorry about that, guys. So we understood that data is a key asset we needed to grow. And around personalization was also a key driver in what we wanted to do. So we have a heavy footprint of Pega at AGL, and we're very keen to maximize that investment by growing the data investment or data feeds into that investment. The other item, I'll skip over the digital channel, but the other item that I wanted to call out there is just around the regulatory pressure that we're receiving. And it's not unknown if you Google AGL that we're under immense amount of pressure from our regulators just around the quality of the information we're providing. And also over the last couple of years, there's been a significant increase in regulatory pressure to energy providers. And we were basically not able to meet our mandated requirements sufficiently with the right accurate quality of data. And then also just around market pressure, like our competitors are gaining more and more traction around understanding and knowing their customers, and that's something that we needed to address. And also around new energy, and I mentioned that before, AGL is very keen to actually start growing into other spaces outside of traditional energy, being gas and electricity. And the only way we could do that was by investing heavily in our information and data platform. So it sort of came probably about September last year. It took us from around June through to September, October to probably build up enough momentum to actually look at, well, what are we actually going to do? And we need to do something that's real. We've done enough things that are sort of happening in the past, or we've explored enough options in the past, but now we need to actually do something that's real. So to do that, we called out a couple of key guiding principles, which I think is always something that I'd recommend, just to ensure that we focus on the value and the key deliverables. So the first thing was just around the architecture. So the architecture had to be something that was sufficient to be able to grow across all of our data platforms, and not just focusing on the first use case, but something that's going to be that we could scale across all of that. We also realized that the increase in regulatory pressure around open banking and CDR, which is coming along, which is also going to happen in the next couple of years, was going to would require us to start sharing that information across our customers and also across different providers and that to our regulators. So we went through this list. We're really focusing on usability, value, redundancy, how are we going to deliver the most amount of value in the short amount of time, around compliance, and also around standards. We didn't really we were keen not to go off and explore again like we have done in the past, but actually align to a industry pattern, industry standard, and something that's scalable. So on the back of these key principles, we came up with a conceptual architecture. Now, the conceptual architecture is pretty much a standard architecture that you see in most organizations. But again, you have to remember where we were at. We were an organization that was too busy innovating, I think, than actually delivering. And so we needed to, we were keen to ensure that we didn't follow that same path again and to address those challenges. So we came up with this architecture, which, like I said before, is pretty much standard across the industry, but we really called out the key items that we want to address and I suppose the guiding principles of the architecture. We also, which I haven't articulated in this slide, we also just highlighted or color-coded where the maturity of these assets were across the organization and came up with a roadmap to address the maturity that was there. Probably some of the key things that we're really trying to drive here was around reporting and analytics for the regulatory demand and pressure that was coming our way. And also, we knew there'd be a significant increase in advanced analytics capability across the organization as we were moving to more of a data-driven organization with key models running and driving decisions and analytics. So we basically went onto Google and typed in data warehousing best practices and came up with the Azure Microsoft reference architecture, which you can all look at on Microsoft Docs. Now, why I'm just calling this out here is because we had a long history of building the cool stuff, and I really didn't want to build the cool stuff. I wanted to just build a traditional data warehouse, but on cool technology. And we're a very heavy Azure shop that's quite widely known. So it was obvious choice for us to start looking at the Azure platform and Azure data warehousing using Databricks and ADF. And again, we weren't keen to repeat our mistakes of the past. So we engaged our key leaders and our key partners with Microsoft and actually pretty much just copied what their recommendation was after receiving significant support from our key influencers that were across the board. So how did we do that? So in December 2018, we actually, I would say, is when we sort of started the project. We started our journey, and there was a significant amount of work leading up to that, and a lot of campaigning and a lot of you're campaigning with key influencers and key partners across the organization. And this wasn't an IT-led initiative. This was very much a business-led initiative, and I think that's where it was so successful. So we started our journey. We gained support from key influencers, so key GMs within customer markets outside of IT. We also aligned with key influencers, and I think that's the key thing there. There's always in every organization, there's people there which understand the data better than the IT guys do, and also probably have better influence inside the organization than the IT people do. And I think it's very keen it's highly recommended us that we actually work very closely with those resources. The other thing we did was it was very use case focused, and I'll talk a bit about that a bit further on. But I've seen so many data warehouse projects fail where we tend to deliver everything in one go. This one was a very iterative approach. So the first couple of months that we built this, we actually only delivered a very, very thin slice, but it was a complete end, cradle to grave data lineage that we delivered. Also just learning and pivoting on the solution. So what we were doing here was groundbreaking for us as an organization. You know, we hadn't done this before. There was resources inside the team that had done this before, but not to the same scale that we were. So it was very much an exploratory phase for us. And again, calling out value was the key thing that we wanted to deliver here. So we didn't want to sit there building a solution for 6-12 months and not actually deliver any value. So the the first thing we did was just build it, pivot it, relearn, retrain, build a team, partner with resources, external partners, bring in some skill sets for a duration, and then move on to delivering the value. Collaboration was key. And when I started at AGL, there was very much a business versus IT vibe in the organization, and I wasn't keen for that. That's not the way I operate. And so we worked very closely in building a completely consistent and partnership team that was across IT and business. There was no, and there still is no IT versus business. We're very integrated into each other. We physically sit on the same location. Well, when we're in the office, we do anyway. I'll just move over this slide because I'm just running out of time a little bit. So current state architecture is very similar. This is our internal architecture. So very similar to the reference state architecture that Microsoft recommend. We do have multiple sources, as you would expect, but we do use heavily some of the Microsoft out-of-the-box tools like Databricks and ADF. We also decided to move down the approach of Data Vault version 2 modeling, which was a massive leap for us because it's not that widely known in Melbourne, to be honest, data modeling version 2. And to accommodate that lack of knowledge, we actually engaged directly with Dan Linstead, who is the father of data modeling, through some of our partner resources, which was a great initiative for a number of our resources to be participating in. That was virtually over. He's based in the US, so that was virtually. We do use analysis services heavily, and that's where it's customized for business utilization. And we use Power BI and Tableau significantly and feed that information into Pega and downstream systems, Adobe, etc. So that was basically what you see there. That was built within 6 months, delivering value to the organization. Was it built to the maturity that you expect from a large organization? No, it wasn't. It's probably taken us 2 years to get there. Well, probably a bit less, probably a year and a half to get there. But we built it and we're delivering the first use case within 6 months. And this is the approach that we actually use just around, and there is a lot more detail to this, but I had to take it out just for confidentiality reasons, unfortunately. But we were very, as I mentioned before, very keen that we don't want to sit here for 6 months, 2 years building the architecture and proof of concepting it out and getting it up to a tier 1 before we actually start delivering it. The first 3 to 6 months of building the foundation, delivering it out as a tier 4, or asset to the organization, but he was delivering value. And he was very agile, but I don't think that really matters too much, but we did follow the agile approach. We were very passionate about weekly, fortnightly sprints and planning, and we did deliver in an agile approach. But does it have to be agile? No, I don't think so. But it was successful for us. So around just automation and speed. So the first, as I mentioned before, first 6 months, we didn't do any automation. It was slow. We were clunky. People were wondering how we're going to get there. And we started with 2 ingestion patterns. It was just basic stuff. 2 source feeds, no coaching, no automation. But now, at a year and a half, we're at 16 patterns now to source data from 16 different data sources. We have co-chained everything. So everything now, well, nearly everything. So most items now are all automatic as we generate new data feeds coming through. That has reduced our table ingestions right through to raw vault from source down to 4.5 days for a new table, which is pretty impressive, including testing and productionization. We've also invested heavily, and we still are investing quite heavily, even now still, on QA automation. But we have created full automation of QAing from CSV to Parquet files through to data warehousing. And that has, again, reduced our time to deliver significantly down. We couldn't do that before. We couldn't do 4.5 day deliveries without test automation. And Data Vault version 2, that was hard for us to pick up, like it was, and it would have been a lot quicker if we didn't implement that. And there was significant discussions about whether we go down that path or not. But again, just keeping in mind that the strategic vision that we did have, that this is not just a once-off data warehouse we're building or database we're building. This is an enterprise data warehouse. We were quite keen to do that. And yeah, I'm glad we invested the time in that and involved Dan, because we would have struggled to probably do that without his help initially. Now, yeah, it was a hard learning curve for us. Where are we at now? So we've got about 1,500 tables from various sources, and about 16 terabyte worth of storage being used. And it's not cheap. It does add up, and that's the choice of cloud computing, I suppose, or the disadvantages of it. Where do we want to go in the future? The way I talk about this now is I think the first 6 to 12 months was all about building the foundation, and the value that we were getting from that was less than the cost to build the foundation, to be honest. But now that's starting to flip. Now we're starting to see that, the cost of building something is far less than the value of what we're going to deliver, because we are delivering now, down from 2 weeks initially when we started loading files into the data warehouse, down to 4.5 days. Our data vault knowledge is strong now, and we understand it. So the automation of the QA feeds is done, or nearly done. So we are starting to see that massive increase in value that we're delivering. There's a large number of users using it. It's feeding through data decision engines. It is moving towards a tier 2 system now. So there's a lot of value that we're getting from this. And we want to continue the growth. So we're predicting that we're going to double this over the next couple of years. Every year for the next couple of years. And we're growing it rapidly. We're continuously loading more assets into this. And we also want to start decommissioning. We haven't decommissioned anything yet. We have decommissioned some users off the legacy systems. We haven't actually decommissioned any legacy systems yet. And that is something that we are planning, we have planned for, and we are driving towards that. And that's a key milestone we want to do. We are very keen to decommission. And it's definitely an FY21 goal for a number of us to decommission 2 of our legacy assets. There is further maturity on the Azure synapses that we want to participate in. And one of my other projects is we are building out the ML platform, Azure ML, which is great, pretty cool, and start moving to auto ML, and some of this just standardizing some of our advanced analytics models. So that's being published and productionized on the Azure ML space, and we want to start using that more. And also virtualization. So we want to start moving towards, we have got other business units that we are looking at basically replicating this same architecture and having virtualized data warehouse assets across different business units. And the other item that we're really keen to start working with or utilizing is DW auto scaling. So that is not available yet in Australia. And we're keen for that to occur, because we do sometimes encounter issues where we're starting to maximize our DWU usage, especially when we're running large queries, and we'd like to look at auto scaling. We've just got to be careful about a cost blowout on that also. Just a quick last slide. What would I do different? Well, probably a lot, but it was, at the end of the day, it was very successful. And I can't stress automation. It has made a massive difference for us. Now, yeah, would I do it earlier? I'm not sure if I'd do it earlier, but I would like to. It's just always, sometimes there's business pressure to really deliver the value and worry about some of the other things a bit later on, and that's what we did. But automation has really improved our performance significantly. And just around POC investment, you've got to be really careful, I think, how much time you do spend on POC, because again, you're not actually delivering anything while you're POCing. But what we did find was that we were running into bottlenecks where our architecture team wasn't able to design the solution in time for the deliveries teams to start the delivery, because we were unsure. This was a new technology for us. We were unsure on how to actually do that. So what I would suggest, and what we have started implementing, is really trying to encourage that architecture team and the DevOps team to be running a few sprints in front of the development team, to ensure there's a clean pipeline or a clear runway of work for the delivery team. There was times when we had delivery teams that were sort of sitting around underutilized. And just for us, we did, and I mentioned that before, we did struggle with data modeling. It was new to us. We had no data modeling experience or no data modeling tools in the organization. Data modeling was done using Excel and Word or Visio. So it was a totally new technology, terminology, everything for us. And we probably did sort of jump in a bit quick, but again, in the perfect world, I would like to have probably involved some key partners a little bit earlier in that were able to help our team out, because it was a bit of a blocker for us. And there is probably some cleanup work that needs to be carried out. That is a legacy of inexperience initially when we started. And just around limiting use of legacy assets, and this is something that's caught me out a few times in other organizations too, is we do tend to invest heavily in the new platform, but we don't tend to focus on things like data extracts out of core systems. And that was the same here. So we're still using some of our legacy data extracts out of our core systems. And that is just disappointing, because you're sort of like buying a brand new BMW and driving around with bolt tires on. So you just don't get maximum value out of it. And again, that's something we're addressing now, but it'd be nice to just make a complete clean slate, I think. And also just around sweating the existing assets. Like, I do think we jump into building new stuff a bit too often. There is a lot of value in sometimes looking at what can you reuse. And to be honest, I probably would look at, is there other options that we could reuse some of our legacy assets that we do have, or re-architect them instead of building from scratch. And the other one that was great for us that we moved to now, but we probably should have moved quicker, or we definitely should have moved quicker, is we have about 40 people in the team still, and we had 2 teams, so 20 each, and it wasn't working. So we broke that into 4, and we've moved to a CI/CD approach now. So each team is working off the master branch. As I say, don't mess with the master. Nobody messes with the master. And we are deploying to production now multiple times a week. Like, we don't actually have we don't have a set deployment rhythm really anymore. It's basically deploy when you can. And so it's happening multiple times a week across 40 people. So that's been a massive improvement. We was taking us initially 2 or 3 weeks to do a deployment into production. By the time we collated all of our different code repositories into our master branch, it was a mess before. So that is definitely something I probably focus on a little bit sooner than I did this time. And that's the end of the pack. Happy to take any questions.
Oh, that was a great presentation, Tim. We've got about 4 questions. I hope you like answering questions around data modeling. So the first question's from Naja. Great presentation. Good to see the drivers of technology choices. Would love to know the approach you have taken for single view of customer, and any recommendations you have around master data management or data catalogs as a business enabler.
So the first one's easy. We haven't done much around single view of customer for a couple of reasons. One is it is something we need to do, which I haven't got there, but also you haven't got as many products in the energy field as you do in banks. So it's not quite as complicated or complex as banks. You basically got, at the moment, you've got electricity and gas and data. There's sort of your 2 products. Whereas banks, you've got 300 different products. So we haven't, but we do. That is actually on our backlog to start looking at single view of customer, especially a CDR, which is mandated, starts coming out. We need to pick that up.
Cool.
And sorry, what was the other part of the question? Sorry.
Have you considered master data management or a data catalog as a business enabler? Yeah,
so a couple of things. So when we were going through this, we just documented a lot of our data dictionary metadata in Confluence straight. It was better than nothing at the time. Since then, we have started investing, and it's not actually part of my team. I'm just a stakeholder in that, but we have invested quite heavily in Azure Data Catalog. And we're also rolling out Alex solutions for data lineage.
Fantastic. I might blast through a few other quick questions. Vinay asked, what was your data model prior to implementing Data Vault?
Didn't have one. It was easy. So I brought that in. So I'm a massive fan of data modeling, even though I don't really understand it, but we didn't have one.
Cool. So Nick P asked, as time goes by and the warehouse matures or gets bigger, what are the key advantages of Data Vault? Is it easier to change? Is it easier to extend, faster to load? So what are the key advantages of Data Vault?
Yeah, so I'm not a great expert on Data Vault. That was really, I left it up to my architects to make that decision. But I think the thing I like about Data Vault is it's great for historic data. It really starts building that out. And I think if you look at your traditional Inmon and Kimball methodologies, even your star schema, they're really, and this caught me out in other organizations where I've led data teams, they don't scale well. Like they grow initially well, and then after a while, it's just very, very complex to actually start scaling as new products start coming along. Now, we haven't found that yet in Data Vault, and yeah, I'm hoping that's the case. And the historic side of it is great also with your different parts of it.
Cool. Rehan's asked this question twice, so he must be very keen. Are you using Polybase on Azure Data Warehouse?
Yep. Yeah, we use it as part of our ingestion.
Yep. And how do you find its performance?
Yeah, look, I think performance fine, but like everything in Azure, well, any cloud, doesn't matter whether it's Redshift or what it is. I think it's all about how you use the services you allocate to it. So let's be honest, cloud isn't cheap. Like, this is quite an expensive data warehouse we're running here. So I think it's fine as long as you put enough resources to it.
Oh, sweet. I've got a question from H, and then we might close out. What types of ML projects or jobs have been developed? How do you determine if they are ideal for auto ML? And what are the business units that own auto jobs? So questions around ML projects.
So ML is definitely, auto ML is extremely emerging, as you probably realise. And we don't really use it a lot, but where we see value in it is around baselining your models. We also see it as value to your citizen data scientists. So like myself, I'm not a data scientist. I couldn't write an advanced model, but I could run an auto ML to give me some idea of the baseline. So that's where we see it going with that.
Tim, there's a couple more questions that I've just received here. You were talking very briefly about extraction, and you used a really great metaphor around running a BMW with old tires. What's your sort of the old extraction tool that you're using and the new one that you're looking to use?
So we're using we're a heavy SAP shop here, so we're using SAP SLT and DI. We're actually, to be honest, we're actually looking what the next tool is going to be. It works okay, but we're starting to look at moving away from batch. So we are still batch driven, and we don't want to be batch driven. So we're actually in discussions with different vendors now about moving to a real-time data extraction tool out of SAP and various other source systems.
Yep.
So next, if you invite me back in 6 months' time, Noel, I'll answer that question a bit more further.
Yep, we'll get you booked in, mate, and we'll get the invite sent around tonight for that one. And a little bit more around your CI/CD, and I assume your data ops journey for the team as well. That's something that is growing in popularity, but is coming from a fairly low base. So it's good to see your sort of maturity in that level.
And I think, look, to be honest, what I saw was more around people and process than actually tool set. The first thing we did to move in that direction was really be very clear on the teams. And having 2 teams of 20 was just not working, and we were very clear on roles and responsibilities. And then after that, so we did lock down our Git repository down heavily, so only key people have got access to it, so to stop the anarchy. And there was a number of discussions around our branching strategy, let's be honest, and there was probably a bit of a captain's call there by myself, because we didn't really agree, or a few people didn't really agree. But it was very much, the hardest part was just getting the people aligned.
Great. All right. Thank you very much for that. Sorry. Yep.
Just one from Twitch. Sorry to jump in. Just out of curiosity, how expensive was it? Just a rough scale will suffice. That's from Sanvi S.
For the project to build it out?
Yeah.
You're not going to get much change under 10 mil.
That's
something like this. Yep. And your run costs aren't cheap either. But again, it's the value that you can deliver as an organization should far exceed that.
On your running costs? What's
running
the ballpark?
costs? Running costs. You'll be looking around 1.5 mil a year.
Yeah, fascinating. Okay,
Yeah.
cool.
Excellent. Thank you.
That's just data warehouse costs, not of course people costs to run that.
Yep.
Cool.
Thank you, Tim. That was fascinating, mate. We'll look forward to getting you back in 6 months. Just a couple of points of note that Tim at AGL did host us last year. In fact, it was, and puts on a decent pizza spread as well. So thanks for that. And also a point that I forgot to add at the start of this talk was that Tim is a famous goat herder and runs so many goats on his farm that he's lost count of them, which I find super impressive.
That's probably a bit of an exaggeration, but yeah.
Near enough too, mate. Fantastic. All right, I'm going to share my screen back now, and but thank you for that, Tim. Really appreciate that. We've got coming up now both Eric and Jeff from that's coming up now. Screen share in a moment. So Eric and Jeff from Splunk. Jeff shared an interesting fact about himself just earlier today, and that is the fact that he, during his university days, he was training in judo, and at one point he was put into a chokehold that was so severe that he passed out from that. So that's quite impressive to get that level of expertise. But Jeff, if you're ready, I'll hand over to you. And just a reminder, we've got a special in Zoom, a special Q&A slot. So if you'd like to sort of steer your questions towards that slot, and we'll of course take them at the end of that. I'll hand over to you now, Jeff and Eric. Thanks.
Very good. Thanks for the intro, Noel. And really good to hear from AGL Tim as well. The DDoS, it didn't end up working out. I couldn't keep you off the line for long enough. Okay, let me just share my screen. So hopefully you can see a blindingly pink presentation. I can see on Noel's face, it's reflected right there. So yes, you're all seeing that. Coming at you live with blindingly pink slides. My name's Jeff, and I've got Eric with me as well. Today we're going to talk about data pipelines with Kafka, Pulsar, and Flink. And for those of you who haven't heard of Splunk before, we're a universal machine data platform, and our ultimate mission is to turn data into doing. So just a quick intro about myself. My name's Jeff Chau. I've been at Splunk since 2018. In the past, I've been an IT consultant doing performance engineering and DevOps engineering. But most of the content online for me will be from my Instagram page, Jeff Eats and Sleeps. And I will be making you hungry because I know I'm keeping you from your dinner, both with this prezzo and my photos of food. Eric.
Yeah, hello everybody. Just wanted to say hello and thanks for the opportunity to co-present with this. I've been with, well, my name's Eric Six, and yes, that is not an alias. That's actually my real name. I've been with Splunk for just a few years now. I came as a customer into Splunk, and with that I was on the PS side for quite some time. I've been around the world helping our customers design and architect platforms, going from everything from a couple hundred gigs a day to a couple hundred terabytes a day. So I'm quite familiar with what we're doing in terms of our customers in the data and big data space, and also where we're moving in the future in terms of looking at data lakes, interactions with that, and the ML space. I hail from America originally. I grew up on a cattle farm, and I'm also very into mountains and climbing, and with that, gin and whiskey. So with that, I will pass it back to Jeff.
Awesome. So awesome Splunk legal slide, legal disclaimer, but I don't think we're talking about any future product today. So pretty irrelevant. More relevant is my own personal disclaimer page. My favorite quote, I may or may not know what I'm talking about. Might have something to do with the fact that I was choked out, unconscious, lost a few brain cells a number of years ago. But in general, I like to take the approach of explaining things like I'm 5, not because the audience demands it, but because of my 5-year-old brain. So before further ado, let's kick this off before my bedtime. Topics for today, pun is absolutely intended, is everything to do with data pipelines. So a very brief overview of Kafka and Pulsar. A lot of people have heard of Kafka, not so many about Pulsar. So just a very quick level set on those. And then we'll do a deep dive into both the Kafka and Pulsar technologies with a performance comparison between the two, which drove a couple of decisions for Splunk product. Also do a quick overview of Apache Flink, another one that most people haven't heard of. But I do understand you guys, as a meetup, had a presentation from someone from Flink in Europe a while ago, if I'm not mistaken. So that'll just be a review. And then we'll cover data pipelines as a concept and see what Splunk has been doing with our very own data stream processor. And we'll finish with Q&A. I've got Eric supporting me today. Direct your questions to the Q&A part of Zoom, if you can. Got 2 thumbs up from Eric, awesome. Alrighty, so most people know about Kafka, which makes it the reigning champion. There are a lot of job ads out there with a request for Kafka skills, and it is the most widely used out there at the moment. Let's do a rapid overview just to level set. As an engineer, I like to be efficient, which is a euphemism for lazy. In other words, I will copy and paste wherever I can. So I decided first, why don't we have a look at the Apache Software Foundation project webpage for Kafka. Needless to say, there's some pretty poor representations of Kafka. This is the main image on the homepage for Kafka. And I thought maybe I'd find a better one on the architecture page. So why don't we have a look at what we found there? That is unfortunate. That's literally what I found on the Foundation project page. But the gist of it is that Kafka is a messaging platform that producers can put messages into and consumers can take messages out of, and the cluster itself can reliably store and route data to wherever. What's more important is how people use Kafka. 3 of the key use cases. Main one being messaging, the classic message queue use cases. There are a number of technologies that do it. RabbitMQ, TIBCO, for example. But mainly publish and subscribe of messages that are managed by brokers, and the messages are stored reliably so that they can be read or consumed by consumers. And that's particularly important for microservices. Second big use case is for application tracking. Normally in a very disparate distributed system, you've got a whole bunch of data coming from all over the place. That might include client-side, web or mobile applications, or in a distributed network, edge servers where you want to collect data into one place to run applications or services. That also leads into the third major use case, which is the simple use case of collecting all your logs into one place using either a tiering of collection clusters in Kafka or otherwise. So Kafka, being the reigning champion, has widespread usage as a pub sub message queue. Thank you for that, that little tidbit of info from the Apache website. 100,000 plus organizations use Kafka. And it means it's got a pretty diverse community and all the support that comes with Stack Overflow. A lot of questions on there about Kafka, which is good because everyone's Googling. It's got a versatile enough feature set that it covers for most data requirements, and that's why it was picked up and is quite widely used at the moment. Interesting to note, some of the challenges that I found, also while Googling about Kafka challenges. Big one is the issues that come with topic rebalancing and the fact that the topics are replicated across brokers as partitions. And when you have Kafka assuming that all partitions are equal in size and throughput, you've got hotspots and storage imbalances, and adding nodes or dropping nodes drives a requirement to rebalance, which is a scalability issue. And I heard that there is a version incoming that will deal with that issue, so I'm just speaking about today. There is an issue around data persistence, an issue that arises where nodes are limited by the storage capacity of the node itself as opposed to the entire cluster, which normally drives the storage requirement outside of Kafka to another storage tier, whether that's a data lake or swamp, whatever you want to call it. Geo-replication, another one worth mentioning, and I'm going to cover how Pulsar deals with that one. And finally, more of a performance engineering issue, which leads into scalability, is the latency of message writes, which is fairly high for those who have done performance testing of Kafka. Now, in the blue corner, we've got Pulsar, and it is the challenger in this scenario. Kafka was built, I believe, at LinkedIn and then moved into the Apache Software Foundation. Pulsar was written in a probably similar time frame, but at Yahoo, and now also is an Apache project. I thought I'd get lucky the second time around looking at the Apache Software Foundation's website at their project page. And this is what I found. Yet another, unsurprisingly now, not valuable diagram. But I guess the gist of it is it does pretty similar things to Kafka as a message queue. But you'll notice one major difference here. It's got what's called a bookie there on the right. And that speaks to the major difference between Kafka and Pulsar in that it has a separated storage tier. There was a blog post by a Splunker who wrote about the difference between Kafka and Pulsar. I'm going to pull up one of his images, which I've copy pasted in here. Awesome, efficient engineering, which talks to the major difference. So the major difference is the separation of brokers in Kafka into brokers and bookies in Pulsar. And that allows for topics to be segmented, so they're slightly more granular. The topics get segmented and then they get striped across the storage tier, which is the bookies. And the bookies are managed by Apache Bookkeeper, which means that the brokers are then separated out and they are stateless brokers. And so the storage layer is the only stateful component. The broker failures, therefore, are handled a little bit more gracefully, simply by modifying the ownership of topics from one broker to another. So it can happen very, very quickly. Let's dive a little bit deeper into the ramifications of this architectural difference. Again, I've taken an awesome image of a Medium article that I found out there that covers it pretty well. Pulsar avoids having to copy large logs simply by breaking them into this more granular unit, the segment, and they're distributed across, striped essentially across the bookie nodes whilst they're being written. The segments are distributed and stored in multiple bookies, and so the topic partitions can be distributed evenly across those bookies, and the capacity of the partition is therefore effectively the capacity of the entire Bookkeeper cluster, as opposed to a single node in the case of Kafka. Bookkeeper is the management tier, which is going to be managing the I/O across the bookies, and that's how it achieves the horizontal scalability in both capacity of the cluster as well as throughput. This is also how Pulsar manages the addition of storage, horizontal scalability. By simply adding bookies to the cluster, you increase the capacity of the cluster. Now, because the message serving and storage are separated into two layers, you've got the ease of moving a topic partition from one broker to another, because it's simply pointing the management from broker 2 to broker 3, for example, if broker 2 goes down. And I'm going to cover that in slightly more detail on the next slide. Last little point there is geo-replication is a first-class feature in Pulsar. It's managed in Pulsar configuration. I've read about this, haven't done it myself, but to perform geo-replication in Kafka, you'll need to involve Mirror Maker, another technology in Apache. All right, so if you are a data engineer, and you may very well work with Kafka on a day-to-day basis, these kind of questions would have come up in your head already. I don't know if any of these have come up in the Q&A, but these three major scenarios are going to pop up in your head, either being an anxious data engineer or as someone who's dealt with this pain before. The three major scenarios being broker failure, or in the case of Pulsar, splitting that out into either broker failure or bookie failure. And of course, the scaling up and down use case. So there's a Splunk blog post there that covers it in quite a bit of detail. You don't have to type in the whole URL. I think it comes up on Google, which is nice. But I'll cover it very, very quickly here. In terms of broker failure, we've already covered earlier. It's simply that the topic manager becomes that owned by a different broker once that broker failure has been detected. In terms of bookie failure, because the data has been stored in multiple segments, which are replicated across the bookies, where you can configure that replication factor. In this particular example, I think we've got a replication factor of 3. Hold on, I'm going to try some presentation magic. Yep, awesome. And call me the presentation savant for nothing. I think that's a good thing anyway. So in the case where bookie failure has been detected or disk failure has been detected, you're going to lose one replica of segments. And that's simply, in the case of bookie or disk failure, going to be rebuilt via replica repair. Okay, we're on to the really interesting part of this preza. We're going to be talking about what Splunk's performance engineering team did comparing Kafka with Pulsar. The last part of this talk is going to cover Splunk's very own data stream processor, and this process led Splunk down the path of using Pulsar over Kafka. So why don't we dive in? There's quite a few slides that are going to come at you in quick succession, and they're also hard-hitting slides, so strap in. Here are some results out of doing a performance test with 1 gigabyte per second ingest and out. A lot of the performance metrics were calculated or collected, latency being one of them. So published latency here is a comparison between Pulsar and Kafka with the same ingest and output. It was detected or measured at a 5 to 140 multiplier in terms of latency reduction. It's a little unfair to Kafka here because we're taking the 99th percentile, and that's what you're seeing mainly in that diagram. But I guess it talks to the long tail of latency metrics that you see in Kafka. In summary, that's a 5 to 50%, 50 times lower latency in Pulsar. Then we've got the number of brokers and bookies used in that same scenario. Well, Pulsar uses 20 to 40% fewer brokers and bookies than Kafka. Kafka, of course, only has that one component because they're a singular combined element. And it's mainly due to the higher bandwidth utilization across the distributed ledgers in Pulsar. There is a difference. There was a scenario where using journaling in Pulsar, which is adding durability to the data store, you will use more. But in the case where there's no journaling, it'll use 20 to 30% fewer brokers. All right, next up is system metrics, another key one in performance testing. CPU usage was 40, I think it was 40 to 60. I've got a different note in here. Less in Pulsar than it was in Kafka. 50 to 60% I've got here in my notes, with full control of memory. We talked about brokers and bookies as well. So the VM requirement relevant to those brokers and bookies is going to be reduced as well. And that's the same number. Yes, I was also talking about with journaling, you add in that data durability, which then is an increase in the number of VMs, bookies, and brokers. At the disk level, latency and throughput are two very, very important metrics. But here's also another illustration of a massive improvement with Pulsar, varying from 5 to 100 times improvement in terms of latency. And relevant to that is the impact on throughput on single partitions. Because Bookkeeper is managing the distribution of storage striping across the bookies, we've got a massive improvement in throughput as well. I hope you're all knocked out by the major differences there. It's pretty amazing to see the differences. And amazing to note that Kafka's used quite widely out there and scaling up. So these issues will become more and more prevalent as time goes on. This is the ultimate slide that captures all of that, and it's great for management. Pulsar has effectively 1.5 to 2 times lower CapEx costs because of the improvement in latency and throughput, and also at 2 to 3 times lower OpEx costs due to its layered architecture and reduction in VM requirement. Send all of your questions and cynicism through to Eric. I'm sure he can deal with all your questions. Now, one more part I wanted to cover from the Apache Foundation is Flink. For those of you who haven't heard of it before, yes, it's got a weird name, kind of like Splunk. And third time lucky, I thought maybe I can pull something good from the project page. Of course, I was given this awesome image. You load it up and you're like, this is yet another squirrel as a service, SaaS. I've got too many of those. The gist of Flink is that it is a sub-millisecond in-memory stream processing platform. And it's going to let you do a whole bunch of event or streaming or even analytical processing on data in stream, whether that's based on time ranges or event-specific identifiers. The feature set is pretty diverse, and it goes way more in depth even for the most nerdiest of data engineers. I know I went into the Apache docs for Flink and eyes glazed over. So I challenge anyone out there who thinks they can deal with all of that. But more importantly, how do people use Flink? Well, it's a stream processing platform, so it is best used to manage the complexity of what normally would be ETL, but in stream as opposed to post storage or post indexing. This means that you can do processing closer to the source, and it is also enabling the event-driven application use case. So it means that you can build data operations into your applications locally and allow them to be more performant than in comparison to having to query a remote database and require increased coordination across the 2 tiers. The third use case I've got up there is just data pipelining, which I'm going to cover in a little bit more detail shortly, because it opens up a data stream API, which lets you work with data in stream. Here's a bit of a summary of Flink. It allows you to do stateful computations on data streams with low latency, high throughput, sub-millisecond. We've got exactly one state consistency, so data that goes through there in terms of the event will be processed individually. And very important to note is the layered API that it offers. And it essentially gives you an API to perform all sorts of different things, valuable things, with data on the fly. Now, the features of Flink, I think most important to raise through that API are those three layers. There's an analytical API. There is a stream API. That stream API is called the data stream API. It's going to let you run aggregations and calculations on streams of data, whether they're based on time, being windows of time by, say, 60 seconds in a rolling fashion, or in a segmented fashion, and windows. The deeper level API is the process function API, which allows you to manipulate events in the data stream individually. And so that proves that Flink is an extremely useful Lego set to use. And we're going to see how Splunk uses Flink. Right. Let's talk about data pipelines, starting with conceptually what they mean. And I've got an awesome diagram, if I may say so myself. All of the pink that you see on this screen here represents all of the data flows that would go through an enterprise. And I think it looks really, really similar to Tim's one that you showed earlier. Disclaimer, I didn't copy it off Tim's slides. I did build this myself. What I'm trying to represent here is, on the left side, you've got all your data sources in the enterprise. On the right-hand side, you've got your consumers and use cases. And in the middle, this is what we're talking about, the data pipeline. You might have data platforms, whether it's operational or the use of data in your enterprise applications, and of course, the data warehousing aspect. But managing all of the data flows is growing in complexity, it's growing in volume, it's growing in velocity. All of that needs a way to manage all of it. And that's where data pipelines come in, right? You want to be able to perform ETL on the stream because otherwise you're always having to play catch up with this increasing complexity of data flows and the increasing agility of business requirements. I'm going to move into our favorite part now to talk about Splunk's approach. And Splunk has used all of the technologies that I mentioned in the talk so far, Flink, Pulsar, Kafka. And the product management team has built Data Stream Processor, which is our relatively new real-time stream processing solution to do all of that. The whole point is we'll have a whole bunch of data producers and a whole bunch of data consumers or sinks, whether that's Splunk or anything else, data warehouse, data lake, data swamp, whatever you have. And the solution is meant to let you filter, normalize, aggregate data in the stream and work with pipelines. What you're going to see next is a screenshot of working with pipelines, data pipelines, in Splunk DSP. So just having a quick look at this screenshot, we're giving the user the ability to manipulate in a visual way on a canvas all of the processing steps in their data pipeline. And this will make the data pipelining complexity a lot easier to manage. In this example, we've got Windows event logs as an example coming through, having the event code extracted and then forked into two different pipelines. And then those might go out to either Splunk or another system. Under the hood, Data Stream Processor is built on Pulsar and Flink, and this is how it works. It's interesting to note that we're in version 1.1 of DSP now, but in version 1.0, that Pulsar component was Kafka. So that's where that performance engineering process and activity really drove that decision to move to Pulsar. And simply in a .1 update, we were able to switch over to Pulsar because in Pulsar you have a Kafka compatible API that lets you migrate from Kafka to Pulsar simply by pointing your clients to the Pulsar cluster. That would have been awesome for the team. Primary use cases, I mean, we've kind of covered it, but managing the complexity of ETL and managing the data stream is key, and you've got a whole bunch of different use cases that come out the end of that as well, and I won't go through that in detail. Any data engineers on here would probably want to see this next slide more, and that is what you can do with DSP at the moment. All of the current supported data sources or ingests, and the supported data destinations or sinks. We're supporting Splunk, as well as most people would be impressed or happy to know that we have support for Kafka, Kinesis, and S3. I've got one very quick example of a customer who's already taking advantage of DSP. This one was a financial services customer who's operating, data at scale. They have more than 1 terabyte of data being generated per day, which was causing downstream performance issues. And there's a lot of complexity in, the operations of that data, getting time to value for their insights, and there's a lot of noise in that data pipeline. So DSP was a proposal to them for them to deal with all that data in stream, convert their metrics, logs to metrics in stream, and filter out a lot of noise in their data pipeline. Their result being able to generate a lot of useful KPIs and send data to the right place and minimize the strain on the downstream systems. Okie doke. Everyone's favorite is the demo. So I'm going to run through a DSP demo, and I am testing the DSP powers that be and demo powers that be by doing a live demo. If this crashes on me, I guess Tim and I will be even. Please don't DDoS me. Right, what you're seeing on screen now is Data Stream Processor. This is the web interface for it. Where is my mouse? There it is. The DSP homepage has links to the major concepts, the docs, and the function references for all of the different processes that you can build in DSP. What we're going to do is click into data management, and we can see some of the pipelines that we've already built. The very first one that I'm going to show you is data routing. So we're reading from a data source. In this case, it is a Splunk Firehose. So this box represents our ingest, and at a glance, we can see the data volume, the traffic coming through, and the number of events per second. As the data flows through all of our pipelines and we're processing them, we can see the latency that each of those steps is adding. And if we're doing any filtering, or routing based on some kind of parameter, how much volume is going into what. And I'm going to click on edit here. And we are given the ability to modify our data pipeline. And say I want to route my data into Splunk, I would simply add this sync function and send my data out to Splunk. And if I wanted to duplicate that data and send it to another platform, I would do the same and write that to, for example, a Kinesis stream. So that's how DSP works in a nutshell. I'm going to take you through a couple of more complex use cases by going back to our list of pipelines. I'm sure you've got a whole bunch of use cases that are coming to mind now. Feel free to drop your questions on the Q&A. The first major one is dealing with all of that noise that comes through your data pipe these days. I mean, it's only increasing in complexity and volume these as we go along. So that is one of the major use cases. How are we going to be filtering that data? Well, this is where we've added a filter function to our pipeline. If I click on that, I'm going to click edit as well so we can make some changes. This is where we're going to start seeing the power of Flink operating under the hood. We're telling this function that we want to filter for source being this Palo Alto or firewall incident log. And also in Flink, because we're given that API to view the data, we're able to do a live preview of results of the data stream in action. And we've got a write to null sync at the moment, which means we're free to test out all sorts of config in stream, knowing that we're not doing any disk operations or write to disk. Give this a few seconds for Flink to do its magic. And we know that the data that's coming through on our Splunk fire hose is 10 or so events per second. And we've got our filter step that is filtering just for those pan incident log files. So when we're inspecting the live preview, this is literally the last 100 events that came through as we turned on the preview. We can see all of the events and the fields that come through in that data. Most important is the body of that data, which we're going to be doing a little bit of manipulation on down the track. But we know that all of our sources are pan incident log, and you can verify that this filter is working by looking at the events that come through in our preview. And then by doing that, we know that we are processing the only events and logs that we want, and we're going to send it to our security operations platform. In this case, it would be Splunk. And then we would remove the write to null. Very, very simple use case. Now, filtering out data by source type is one thing, but for anyone who's worked with a certain very common source type, Windows event logs, will know that even within that source type, we've got a lot of noise. So at the event level, we want to be able to do data manipulation to extract only the useful data fields. And that's what we're going to look at in our third use case. Formatting and masking. This is the most complex pipeline that we're going to look at tonight, but looking just at that pipeline, what it's doing is we've got a filter that pulls out Windows event logs, where the source is Win event log security. And moving along this pipeline, we are converting the body to a string. That's an event-specific function. And then doing string manipulation to pull out event codes from that Windows event log. Because in this particular use case, we know that there is some data that we need to mask. If I click on this extract event code function, we're seeing that we're extracting with regex just the part where in our data which says it has an event code. And that will allow us to fork our pipeline into this essentially gate, which deals with event codes of 529 or not 529. And in our use case, we know that under event code 529, sometimes we've got usernames where the password is inadvertently submitted. Let's have a look. If I switch on the preview, we'll be able to see some of those passwords in these events. And you'll see downstream in our pipeline, we have a function to mask that sensitive data. Okay, here we go. So we've got an if statement that extracts the event code 529, and doing a preview of that data in stream, we can see that all of the events have an event code of 529, so our filter is successful. And what we want to do is extract the user account field, because we know that that's where that sensitive data exists. And let's preview that field extraction. Here we go. So unfortunately, we've got some accidental use of passwords in the user account field. There might be a couple more examples here. Here we go, a great password, something clever 2019. And we don't want this written to disk, or we don't want this written in our data platform. So we're going to use this super useful function to mask that sensitive data. Before I show you the preview, got ahead of myself there, is to define a field masking in this function. So here we're doing a base 64 encode of the user account field. If I click on preview, we'll see that all of our user account fields have now been masked. And now we're going to select all of those fields that are useful and only then write it to our data platform, Splunk, with our user account masked. That one's a great use case, which is a big one for PII data that you may be dealing with already in production. This is a visual way to manage all of this. Something I didn't get to show you earlier is you can work with all of this in the canvas, but at the same time, you can also extract the query language that underlies all of this. In here, it's called SPL v2, Splunk Processing Language v2, and represent your entire pipeline in that query. And as you're building it out, it's going to be building out this SPL as well. Now, I'm going to just skip over the fourth one and jump into the most exciting one, in my opinion. That is drift detection. And this is where we're starting to use some of that auto ML. We're building machine learning into our pipeline, and it is as cool as it sounds. Here's our pipeline, where we're reading from the fire hose again. We're filtering it for firewall traffic. And the use case here is to use machine learning to detect drift. So I'm going to skip over a couple of the functions here and just highlight this drift detection function. It's a out-of-the-box machine learning algorithm in DSP as a function. And what this is doing is allowing the system to apply machine learning to data in stream, which is pretty impressive. Now, because this is extracting out the firewall traffic, the use case that represents this, this pipeline is detecting any massive changes in network traffic in our firewall data. So you'll see here, it's a little hard to see at the bottom. You've got the firewall traffic data that comes in, and then after this drift detection function, we have a label which will tell us whether there is true or false, confirmed drift or not, as well as an output, and that number is the certainty. You know, say if it comes out with a true detected drift with 96 as the output, it means that there is a 96% chance of this drift detection being true. Now we want to write both of those to Splunk, and we're going to see what that looks like if you have an operational platform. We're going to use Splunk in this example, and because we're sending the events here, it's been long enough, I better log back in. We're now only sending a very strict subset of our data fire hose into Splunk, which for anyone who's using Splunk would be an awesome benefit if you're trying to deal with a lot of noise. we can see the data that's coming into our data index, and these are the Windows event logs and firewall traffic syslogs that we've picked up. Now we have a dashboard called the Network Investigation Activity Dashboard, which is going to use that machine learning algorithm, that pipeline that we just showed, and only the drift detected events are going to be pulled out into this dashboard. So again, a lot of people are dealing with alert fatigue. If you know and you work backwards from your high-level use cases, you can build alerts from scratch where those are critical. And in this case, we've detected a drift in firewall traffic, and that firewall traffic captures traffic flow from the corporate network to individual workstations. I don't know if we have any security engineers here, but this is a major use case to detect some kind of data exfiltration or some kind of strange behavior from the network. Now you'll see this is where the drift was detected from this corporate server onto this workstation. And looking at the network traffic diagram below, you'll see that the drift detected event was here, where the label was true, and we had a value of 99.29. And you'll see that the traffic indicator here did spike. If I click on that and we look down here, we know that the machine was this IP address. Clicking on that destination IP, we can drill all the way down because we have the Windows event logs of the processes that run on that machine. And for any Breaking Bad fans, you know that we've got a rogue chemistry teacher, and that was the cause of this spike in network traffic. That was the DSP demo. I hope you found that interesting. I know I did. It is way past my bedtime and dinner time, so hungry and sleepy. But we'll stick around to answer a couple of questions if you have them. Eric, yeah, thanks for answering questions as we went along. Did you want to add anything? Did you want to mention any questions that were really good?
Yeah, I just wanted to add on, for those of you that are familiar with the Splunk platform currently, DSP is not a component of our current core platform. This is a standalone product that's meant to sit in front of a Splunk instance or Splunk deployment. And in fact, it's more than just that. It's we realize that the value of data doesn't necessarily need to land in Splunk. So we have the capability to, as Jeff mentioned, route that data outside of Splunk and drop this into S3 buckets or drop this out into HDFS or other type of data sinks where those will eventually probably land in data lakes, where at some time later we can do streaming analytics on those. So this isn't just for customers that have Splunk. This is actually a separate product in the Splunk portfolio. So I just wanted to throw that out there.
Now, there was a part of the demo that I skipped over, and that was aggregation, just in the interest of time. But aggregation, for anyone who's dealing with a lot of metrics, you want to get an aggregated calculation of, say, the last 60 seconds worth of a certain metric. That's how you would do that in a pipeline. Any other questions?
We had a whole bunch of questions in Zoom, but Eric's been really diligent at sorting them out.
Awesome.
Were there any questions on Twitch or Slack?
Yep, can you hear me? I've got one
Yes.
from Twitch. So Sam VS, he was asking, do you have more details on the testing that was done, like the versions of Kafka, Pulsar, like the methodology? Is there a public white paper available, or potentially a Git repo where you've got all the code, etc.? Sorry to put you on the spot.
I'm sure there's a lot of valuable info to extract from that performance test. I don't think Splunk has made that publicly available anywhere, unless Eric has some magic public repo.
I've got, I think, another question from Melody Yang, I believe. Is that Melody Yang from AWS? She's asking, can you use the DSP to join multiple streams?
Yeah, of course. So you can have 2 inputs and process them and do all those different things. Yeah.
Yeah, awesome.
So to jump back to the question about performance testing, if you go to conf.splunk.com, this is our global user conference we hold every year. There was quite a bit of presentation material around DSP from last year. There should be some performance notes and testing numbers in that. I can't find it right now, otherwise I would share it. Otherwise, we do have our global user conference coming up later this year, and we will have some very, very heavy deep dive sessions into DSP itself. So conf.splunk.com later this year, October-ish timeframe, and free for all.
Yeah, important to note that it's free for the first time. Normally it's hosted as a physical event. This time it's fully virtual and it's been offered free to the public. I'll be there, but yeah, would be really good to see anyone here at Splunk Conf.
Yeah, cool. Feel free to share the details in the chat and we can drop it into our Slack group and things like that. I'm sure there's a bunch of people using, oh, okay, Eric's already done that. Well done. Yeah, there's a bunch of people that are using Slack on the group. So yeah, thanks again to all of our speakers. Really awesome stuff. Yeah, we might just kind of have a bit of a chat now. I think, Michelle, did you want to give one last plug to AGL Data?
My whole display just changed right as I was heading for unmute. My head moved. Yes, so for anybody who missed out, we are doing a virtual version of AGL Data or AGL Data, depending on how you want to slice it. Someone asked about ticketing. It's not open for ticketing yet because we're still wrangling with online ticketing platforms. But you can do a save the date. So the 30th of June till the 2nd of July, but it's not full days. So you'll be able to actually get some work done or stretch or talk to your family or other things that people need to do when they're working from home. So thanks, Peter.
Yeah, cool. So that's Michelle Playfair, AGL Data. I cannot recommend AGL Data conferences more highly enough. They're just absolutely awesome. You know, so well curated. The team is just, you know, really impressive. So you're definitely not wasting your time nor money getting along to one of these. So yeah, give it a go. Another bit of a shameless plug about Data Eng Bytes. This is more of a community-driven conference, so you're going to definitely get a different product at this conference, you know, and I think we're going to have a lot of fun with it. We've got a great team like Francisco Liwa, Leo Hoare. He's put our website together. He's a data engineer, but also an absolute gun at front end. So thank you so much. Katie Peterson, Karen Davis, Simon Aubrey's just done so well, like, you know, helping out and, you know, getting everything organized. And not sure what this guy's been up to, but well, he's been doing all right. So yeah, and a big thanks to Tim Gerber and Jeff Chau and Eric Six, our speakers tonight. Feel free to get in touch if you'd like to present again or present at a future data engineering meetup. We're on again in a couple of weeks on the 18th of June. So stay tuned for speaker details for that one. I think it'll be a lot of fun again. Hopefully you got a lot out of tonight. Yeah, so, and just let us know in the Slack group or on Twitch or wherever, you know, what you thought of the format tonight. We're doing a bit of an experimentation in terms of format and, you know, the different platforms that we're serving the content up on. So yeah, keen to hear your feedback and what you thought of everything. Really what we do here is for you, it's for the community. So yeah, just thank you so much.
Thanks for having me, and Eric.
Thanks, Jeff. Thanks, Tim. Loved your presentation as
Thanks
well,
everybody
mate.
for your time.
Awesome.
Ready.
Thank you.
Cheers, guys.
Thank you everyone for coming along tonight. I think it was
Yes.
great to have the presentations and the lively chat. That was fantastic. Some great questions tonight.
Thanks everyone, and good presentation and talk. Really lovely.
Cool. All right, we might sign
Thank
off
you.
now and see you in about a fortnight's time. So keep being awesome data engineers.
See you guys.
See you.